So like I said, guys, today we're going to start our discussion on risk analysis, okay? Don't forget that this is the second major step in carrying out your risk assessment. The first step is, we said, is the risk identification. And then the second step is risk analysis. And then the last step is risk evaluation. Now, these are the major steps for risk assessment. There might be some things that you can do at the beginning, like establishing the scope and purpose and the concepts of your criteria and all that of your risk assessment. Also, if you talk about monitoring the controls, the performance of the controls or the effectiveness of the controls that you made, communicating, documentation, and things like that, which usually forms part of the broader overall risk management process. However, in risk assessment, this may also be considered. But the core processes in risk assessment are risk identification, risk analysis, and risk evaluation. So risk analysis, like I said, is the second step of the risk assessment process. And what does risk analysis do? How do you analyze the risk? So to analyze the risk, basically what you need to do is to identify or determine the consequences of the identified risks. Okay, so like you see, last time we discussed in detail the issue of risk identification. Now, I probably have a number of risks that has been identified. Now, this risk, you want to determine the consequences of this risk, okay, as well as the probabilities of this risk. You remember in our previous discussions, we said risk can be defined, okay, as the consequences and the likelihood of those consequences, the chance that they will occur, okay? Well, when you talk about consequences, it's more like you're talking about the hazards itself. You are describing consequences more or less a description of the hazards, okay? What is the severity of the consequences? When you talk about the likelihood of those consequences, then this is the risk, okay? The likelihood of harm to occur as a result of those hazards. Now, so you define the consequences and probabilities for identified risk events, okay? You take into account the presence or absence, okay, presence or not, and effectiveness of existing controls. It is very, very key as well. Once you identify the consequences and probabilities of the identified risk, you have to think about the controls that are put in place. That's existing controls. You remember we discussed this in some of the lectures. Now, when you take into account the effectiveness, okay, of the existing controls, or how does this help to reduce the risk? Whatever is left from this is called the residual risk, okay? That is remaining risk that still needs to, which may be acceptable or may need further treatment, okay? So this effectiveness here means simply that sometimes you may have controls, but they are not effective. Okay, so you have to take this also into consideration. How effective are the controls that are being put in place? Also, the controls, you have to understand them in the context of the hierarchy of controls. Okay, lower level controls will have lower effectiveness, while higher level controls will have higher effectiveness, and better effectiveness, or will be more effective. Now, the consequences and the probabilities are then combined to determine level of risk. As I said, this is simply using multiplication formula. Okay. Now,
Teacher,
yeah.
the slide doesn't move.
Where are you now?
Just logging. You can't see the slide.
Okay.
I don't know if it's on me or
Now?
yeah, now it's more.
All right, so I'll keep it this way then. Okay. So you can see here, as I said, that we have the risk, which is basically an expression of the consequence, okay, as well as the likelihood. Okay, and then we have the determining the risk is basically multiplication, simple multiplication formula. And like I said, also you have to take into consideration existing controls, okay, to determine the residual risk. Now, the purpose of analyzing risk is to gain an understanding of the risks that are of importance to the organization. Okay, now, why do we need to analyze this risk? Why don't we, once we identify the risk, why don't we treat all the risks? Okay, like I said, sometimes not all the risks are of critical importance to the organization. I wouldn't want to say that they are not important at all, but they all have levels of priority. This not only depends on the amount of time, resources, material, financial, human resources that you have, but it will also depend on how this risk contributes to the overall bottom line of the organization. For example, we talked about the Pareto 80-20. Okay, for example, 80% of those risks or 20% of those risks identified, okay, 20% of the risk identified is what causes 80% of losses in the organization. Okay, it's called the Pareto analysis, which is cause and effect. So Pareto analysis believes that not all 100% of the risks leads to 100% of the losses. Some of those risks are more important than others, okay, in terms of the overall losses to the organization. So according to Pareto, 20% of those risks is actually responsible for 80% of the losses. So in that case, every organization is always working within constraints of time, constraints of resources, and moreover, they need to make risk-based decisions to deal with what has more priority before dealing with other things. In that case, they will want to deal with the 20%, the most critical 20%, before giving any consideration for the other risks that were identified. So that's the purpose of analyzing risks. So it's not every time that the risk assessment is needed. Sometimes what you simply need is just a hazard analysis, and then put in place controls to control the identified hazards. But after carrying out the hazard, you might need to go further to do a risk assessment for those risks, as we said, 20% that contributes to 80% of losses. So the risk analysis process you can see in this arrow, firstly, is to assess the severity of consequences, okay, determine occurrence probability. So basically, again, risk analysis mainly consists of two domains. One of them is the consequences, very key, and the other is the probability, also very key. Okay, so you have to identify these two. The next is to define the initial risk. Now we're saying initial, right, here, because this is the initial risk determined from the consequences and the probabilities. All right. Now, this, by the way, is going to be taking into consideration existing controls, okay? Because basically, when you define at the workplace, at the sites, at the facility, it has to be in light of what controls were already existing. Next, you try to reduce this risk. If the initial risk is unacceptable or is intolerable, is not within your ALAR region or ALARA region, you now come to this, which is the reduced risk with controls. It means you propose additional controls, you propose new controls that can help you to reduce the risk. Now, the new risk, which is called the residual risk, you assess this. You can assess now the residual risk and see if this risk is acceptable, okay? It is acceptable. Otherwise, you can move towards another treatment. And in this case, when you say treat other treatment, okay, and they're putting in place some provisions to do that. Or you could be using changing the risk treatment controls that you suggested in the rules that are more effective. You could, you could do research to find out a way to, or you could totally just abandon the project if the risk is not acceptable, okay, in any way. Now let's look at this. Now this is the risk management framework, and you can see that for risk analysis, there are various tools that can be used. One of them is risk analysis, which is called the cause analysis. That's identifying the causes of the risk. You can see cause and effect analysis, causal mapping, design safety review, fault tree analysis, FTA, management oversight and risk tree. And here you can see we have risk analysis, likelihood and consequence analysis, like the bow tie analysis, the analysis, fault tree analysis, failure mode and effect analysis, hazard, job risk assessment, layers of protection analysis, preliminary hazard analysis, okay, strip bow tie risk assessment, and SWIFT. And you can have risk controls analysis like bow tie as well, design safety review. So all these are various methods, okay, that can be used in risk analysis. You can say some of them, we're probably going to discuss about some of them later on. Now let's discuss the risk factors, okay, which are the components of the risks. Components of risk derived from an identified hazard and are estimated and measured to produce a risk score. Now, risk factors basically, as we said, mostly is the consequence and the likelihood or probability. Sometimes some people include other factors aside these two. Okay, basically it is consequence versus probability. In some cases, we may have others. We may have other factors. Okay. And when you have other factors, usually this may be included in the formula through various ways. It could be multiplied with the severity and the likelihood and the consequence and likelihood, or it could be divided, it could be severity multiplied by the likelihood divided by this new factor, and things like that. There could be other modifications to this formula. So risk assessment generally have two-dimensional risk scoring systems, and that is two factors. This is in general. As I said, severity of consequence as well as the likelihood, probability of occurrence. Now, there could be other risk factors, as I mentioned. We could have exposure, which is used as a general measure of exposure events and units. We could have frequency of exposure, how frequently people get exposed to this, and this could be based on unit of time duration of exposure, vulnerability, okay, how vulnerable people are, especially using security threat analysis or in emergency management. Vulnerability is common and generally refers to weaknesses in the system that are factored into the risk estimation. Detection of failure, usually in FEMICA or in FMEA models, because we're talking here about equipment systems. As a third risk factor in the risk level scoring system, the detection rating is based on estimate of how easily the potential failure could be detected prior to its occurrence. Control reliability could have that, which is used in machine risk assessment, and factors reliability of a selected control into the risk estimation. We have prevention effectiveness, which is sometimes used in FMEA and other methods to evaluate a control's effectiveness in preventing a failure from occurring. Actually, this prevention effectiveness can be used along with the risk control, the existing control. All right, you already identify the risk as consequence multiplied by the likelihood. Now, this risk identified, you want to bring it down, you multiply it by the prevention effectiveness, okay, to get the initial risk. All right, this gives you the initial risk. And this prevention effectiveness applies to what you call the existing controls, okay? You want to know how effective are existing controls. And of course, when you make additional controls or you suggest recommended controls, you still need to use the prevention effectiveness to bring down the initial risk even further, okay? This is the initial risk. The initial risk now could move to what you call the future risk, okay? That is after implementing additional controls. Now, consequence analysis. How do you determine the consequence of risks, identified risks or identified hazards? So basically, consequences are the results. That's what consequence is all about. What is the severity, the impact, the results, the outcomes or losses of an event caused by those hazards? All right. Now, consequences most often refer to the damage, okay, or harm caused to people, assets, property, or the environment. So the assessment team determines the nature and type of consequences that could result for exposure to a particular hazard. So when you have that kind of hazard or event, you need to determine what are the type of consequences that can happen. Basically, like we said, it's usually in the domains of people. Okay, assets, damage to the assets and the property. Okay, damage to the environment as well. There could be other kinds of consequences in terms of business consequences, business interruption. Okay, delay in or downtime. Okay, you have delays, shutdown, business losses. All these are examples of consequences. So you have to determine what are the kind of consequences that you're going to consider, and then how to estimate or determine those consequences. Sometimes they could be determined based on preset standards. Sometimes determined based on engineering analysis and calculation, consequence modeling, and things like that. So a single hazard or event may produce a number of impacts with various magnitudes, that's level of severity, and could affect multiple assets or stakeholders. Okay. So for example, when you talk about environmental consequences, this may cover an entire area. You may have to determine what size or area of the environment this is going to cover. Okay, is it going to simply just cover a few, meters or square meters of land, or is it going to cover an entire region? Okay, what's going to be the far-reaching effect of these consequences? Might be, for example, an explosion at a chemical plant. An explosion at a chemical plant that is going to affect neighboring business areas or industrial areas, or what we call domino effect. All right, it could be an explosion in one tank that will lead to an explosion in another tank, and this may even spread to other industrial areas that are separate from this particular area. These are all consequences, and this could be determined by modeling or determining these consequences. Similarly, the assets and buildings that are around this, where the location of the hazard, what are the result consequences to these assets? This will involve also knowing the value of those assets. Okay, the cost of repair or cost of replacement of those property and assets. Now, the assessment context, assessment's context determines the types of consequences analyzed and stakeholders affected. Now, risk usually is evaluated for the worst credible case rather than the worst conceivable case. Okay, all right, there's a difference between both of them. When you say worst credible case, okay, it means that basically what is realistically possible. Of course, you basically risk, you have to determine risk based on what you think that is may happen, not what you conceive that may happen. Okay, what is conceivable is outside, could be outside this world. Okay, could be extreme. Okay, when you say conceivable, this could be extreme, and even though it may be possible that it happens, but it's something that is very, very unusual. Okay, the probability is very low. Okay, it is, this worst conceivable is extreme and usually has a very low probability. So in that case, we consider the worst credible case. Okay, which is something that is, and is still realistic. Now, consequences are the result of outcomes, as we said. Now, as a primary risk factor, that's the consequence. The severity of the severity levels of the consequence to be used in assessment must be determined upfront. Okay, must determined upfront. That is when you're doing your hazard analysis or hazard or risk it. During development of the context, this will include the types of consequences and levels of severity. Okay, what kind of consequences are you willing to consider? So it is important that severity categories are clearly defined so that consequences can be consequently ranked or scored by the risk assessment team. So you can see here, which is the consequence levels for severity category. When you define at the initial stage of your risk assessment, when you're defining the concept, the context, you need to define something like this table, okay? Where you identify your severity categories and descriptions of those categories, all right? For example, your risk, will it be considered as something catastrophic, as you can see here? And that is a fatality or permanent total disability when you have more than $1 million in losses. Or is it going to be considered as critical hospitalization, permanent, partial, temporary disability in excess of 3 months? This is terms of people, okay? Injuries and illnesses in terms of people. Financial loss could be total in terms of property, okay? Property, environment, business, okay? You could monetize all these losses. Other losses can be converted into the financial equivalent, okay? And then you can determine how much you've lost in terms of, costs, loss, repairs to your property or replacement of property and assets, damage to the environment, cleanup operations or fines that you have to pay to government, business losses, that what you've lost in terms of downtime, shutdown of your plant, other business losses, the customers, partners, investors, all these things that you've lost, you have to be able to quantify them in terms of their financial equivalent. So anything greater than 1 million, and this, by the way, may change. It depends on how large the organization is. Okay, depends on how large the organization is. So this usually is determined, the severity levels, based on your risk tolerance. Okay, how much risk are you willing to accept as negligible? Okay, something now in the region of $0 to $10,000 is considered here as negligible. For some other organization, $10,000 may be, it may be $0 to $1 million may be considered as negligible, depending on how large, how complex the organization is. Similarly, negligible here, first aid and minor medical treatment. Okay, life is very important. Okay, because we cannot replace life. However, this can also be modified. This depends on the risk owners. Okay, risk owners, that means the senior managers. They are the risk owners, and they are the ones that decide on what level, what's their tolerance of risk, how much risk are they willing to accept. Also, there may be guidelines or standards based on the specific industry that they are operating in, or based on international regulations like environmental regulations from EPA, or requirements from the authorities, the local authorities, that's the government, the ministry, or regulatory authorities, may limit how these risks are being perceived, especially because of the protection of life and environment. Now, this is another example of what we call severity categories, okay, or severity levels. You can see here that we have it in terms of injuries, okay, or casualties to people. We have in terms of safety, okay, in general, right? We have damage of property, how much is its financial loss, how much environmental impact is gotten, how much public impact, and maybe you could, depending on the organization, they may come up with some other criteria to characterize the severity of the risk and then describe them as well. Okay. Now, for something that is catastrophic here, fatality, which means death of people. Sometimes this could also be specified how many people. One person is considered catastrophic, or usually one person, of course, the death of one man, we consider catastrophic, but maybe it depends, as well. Also, it contains critical, could be permanent disability, life-threatening, hospitalization, serious when you have lost time. That lost time, people don't come to work because they have been hospitalized. Moderate is medical aid or restricted work. Minor, just first aid is required. Something external disaster response is required. Internal response For example, external means you need firefighters, you need civil defense, you need these people to respond to the accident. Internal disaster response means this could be handled internally in the organization. An emergency response is this is not the disaster now. This in these two cases where we describe them as disasters, which is greater than an emergency in terms of its scale, in terms of response. But emergency could be something that happens it is routine. It is not something that is outside outside what is natural or what is normal. Something that is routine that happens once in a while. In this case, you have emergency response. However, you still need external agencies to support in the response operations. Moderate, you have potential emergency response. And here you have minor reportable occurrence. Okay, there's no need for a response, but it needs to be reported. Now, in terms of financial losses, you can see here saying greater than 250,000 USDs. And the last one here is up to 1,000 USD. And like I said, this could also change. This could be modified. Environmental impact. How much impact does it have on the environment? It could be major. All right. Maybe you could have off-site release, repeat serious violation, release contained within the facility. Okay, which means it's a release that is contained within the facility, doesn't go outside. Okay. Contained within facility, it has minimal impact, or contained within facility has no impact. Okay, so it could be something that goes outside the organization, okay, or it's something that is contained within the organization. Now, for public impact, you could have serious impact, large impact on the public community, or serious impact but on a small community, minor impact on families or in the neighborhood, minor impact on an individual, and minimal or no impact. Okay, so basically this is how you describe some of these risks. And when you say serious impact on large community, some of them are subjective terms, but some of them can be also viewed objectively as well, especially when you have a figure. Okay, you have a figure like the cost, okay, or number of fatalities, or number of injured persons, or the nature of the injuries. When you have specific information, depending on how specific you are, it could be objective. And sometimes when you have some statement this way, this may depend on the intuition, okay, of the risk analyst, as well as the decision of the team, okay, the risk assessment team. If you have a team, this will come down to the consensus of the team members and how they choose to categorize or characterize the identified risks. So the next thing is consequence analysis, which is KRA. We know the KRA is outside the scope of this course, okay. But KRA is also one of the ways, or consequence analysis is basically used when you're doing KRA, quantitative risk assessment. We mostly use in the petrochemical industries and oil and gas industries. Okay, so basically use KRA to understand the consequences of release or loss of containment when you have release of gases or of fluid into the environment. What's going to be the consequences? Okay, or some other kind of hazards. Okay, chemical hazards, petrochemical hazards. Okay. This could lead to explosions. This could lead to fires. This could also lead to toxic release. Okay, so basically in this category, it could be either in terms of blast, explosion, and fire, or it could be in terms of release of toxic materials into the environment. Okay, toxic and other forms of hazardous materials that could be biological viruses and things like that being released to the environment. So consequence modeling here models the consequence of this release, basically by modeling the dispersion or spread of this. It could be how far the pressure, okay, the overpressure from the blast is going to travel, how far, what area is going to cover. Some models might also consider shrapnel, pieces of material flying away during this loss of containment. Also the heat from the blast or from the fire, how this is going to spread. Also the spread of liquid or fluid from this. It could be gas or it could be liquids coming from this release of material. What kind of fires these are going to is going to generate, and what's going to be the heat from this fire, and what's going to be the consequences, what are the materials or properties that are or assets within that area, and how this will be affected. Also lives that will be lost or injuries that may be sustained due to this, potential environmental damage, and all this. So basically all this is called consequence modeling or consequence analysis. So rather than simply just looking at the matrix here, where you try to, based on historical data, right, and based on some other form of analysis and information and assumption, engineering judgment, you determine the consequences of a particular hazard as falling in either of these categories. Consequence analysis may actually provide you some objective data that you can use to categorize the severity of the hazards. And this will involve using some tools. These are some resources I've included here that it's possible to refer to these resources for more information on consequence analysis. And this could be treated as a separate course or treated as a topic under QRA's quantitative risk assessment. Okay, but I've included in this course to make the discussion complete. However, it's something that requires detailed discussion and more scientific and engineering discussions. Okay, so next risk factor is the likelihood. Okay, this is another risk factor, the likelihood aside the consequences. Now, how do you determine the likelihood of the risks? Okay, this is another risk factor, which is the likelihood. Now, to determine the probability or likelihood, this generally involves one, a review of relevant historical data to identify events or situations which have occurred. So historical data may tell you, and basically likelihood itself is what tells you what the risk is itself. Likelihood is basically the definition of the risk. So you could get this from historical data. Okay, historical data will tell you the occurrences of this in the past and how likely is this to occur in the future. Okay, but this could also involve understanding the current environment. Okay, because environment could have changed, things may be more likely to occur, so that may lead you to use predictive type techniques such as fault tree analysis and event tree analysis. Okay, fault tree analysis and event tree analysis may help you to understand or analyze the scenario and the event in such a way that you may be able to determine the likelihood of things occurring. Now, you may be able to, for example, identify potential causes of failure and probabilities of those failures occurring and what those failures could lead to. It could lead to multiple, it could be caused by other things, and what is the likelihood of those other things occurring. And like this, you can come up with an aggregate likelihood. Usually, basically, you might need statistics, probability and statistics when you go deep into this, trying to understand what is the likelihood of this happening and what could lead to that thing happening, and what is also the likelihood of that happening, and then what could lead to that. Just like you do in fault tree analysis, where you're trying to identify the root cause, okay, the root cause of a top level event. And for each level, you have to identify what is the likelihood using and or. And basically, and or could be considered as probability, and then you can combine the probabilities until you know what is the final probability of an event happening. Now, also you can use a structured schematic process guided by a qualified, knowledgeable experts, okay, which is more common, okay, where you use expert judgment to determine the likelihood of an event occurring, and a risky event occurring. So basically, we have three approaches. One of them is to consult historical data, okay, and now with the use of modern day technology like machine learning and artificial intelligence, you may be able to mine this historical data and determine, based on some indicators, you may be able to use historical data to determine future occurrences of risk and predict the likelihood of future risks. Or you can use predictive techniques already that exist in the as one of the tools of risk assessment, such as fault tree analysis and event tree analysis. And lastly, you might use expert judgment to determine and by the way, expert judgment can also be as a result of consensus of more than one expert, okay? Not just one expert, you could have 1, 2, or 3 experts or your whole risk assessment team coming to an agreement on what is the potential likelihood of a risky scenario. So any available data used should be relevant to the focus of the the assessment. So here you could see we have some categorization as well for the likelihood. You can see what is frequent. Okay, it could be high probability of occurrence, happens often, expected to happen several times in a month, or 1 in 100. Okay, 1 in 100 means once in 100 days. It could mean one time in 100 opportunities. You know, if something that an activity that is done 100 times, if an accident occurs once in this 100 runs of this activity, you could consider something as frequent. So all this also is determines. It depends on how you want to categorize this risk. There's no set when you during the context of your risk assessment. Okay, when you define the context of risk assessment, how you determine this. So you can see this also says here once in 1,000. So we have various scales starting from something that is more frequent to something that is very unlikely. For example, you say 1 in 1 million. For example, that could probably mean that it happens only once in 1 million days or once in 1 million hours. Okay, considering that it's possible to happen once in an hour. So once in 1 million hours or one time in 1 million opportunities. Okay, that's 1 million times that event was done or the particular activity that was being carried out. So this means it's almost improbable, almost unlikely, very unlikely to occur. This is another one. You can see 1 to 5, where from unlikely down to frequent. And you can see here has occurred more than once within the last 12 months. Okay, this is another definition. Conditions exist for it to occur. Here it says unlikely to occur, has not occurred within the last 5 years, or conditions really exist for it to occur. So basically, you could study various categorizations and descriptions of risk likelihood and come up with something that you feel is worst and probably is more suited to your particular organization, your particular environment. Okay, sometimes some companies already have fixed templates that they use, or they simply borrow a template from a particular standard, okay, or a particular guideline. Okay, so we have this as well here. Time period in a century, that is 100 years. Okay, all right, and here it says that here a decade. Okay, remote means it once in every 10 years. Okay, every 100 years. This is once in 10 to 100 years. Annually, 1 to 10 years. Monthly, 1 to 12 months. And weekly, 1 to 4 weeks. It happens every week or every 2 weeks and things like that. So you can determine the likelihood frequency this way as well. Okay, and there are probably other categorizations and characterizations like this. Okay, something else you may want to look at is the exposure of the risk. Okay, the exposure basically means that you could consider the likelihood of occurrence, but there's also something called exposure. Sometimes exposure takes precedence over occurrence. Okay, because why it might be the likelihood of occurrence might be low, exposure, one-time exposure to it poses significant level of risk. Okay, serious risk, serious injury and losses. Okay, so basically these types of risks, you may want to consider the exposure rather than the likelihood of occurrence. You might want to consider the likelihood of exposure instead, or you may have some formulas that incorporate both of them, both the likelihood of exposure as well as the likelihood of occurrence. So here you say, for example, where historical data shows a very low frequency of occurrence, it may be difficult to properly estimate probability. Okay, therefore it may be necessary to consider exposure frequency, time, and duration of a certain hazard or event in the likelihood analysis. Okay, so you say we have low frequency of occurrence. Okay, in this case you may want to go for the exposure frequency. Okay, this may be more realistic. So exposure is an indication of the extent to which the organization is subject to the consequences based on the amount of exposure in numbers. This can be measured as the frequency of an event or exposure, its duration, and other assets exposed to the risk. So some variables may include the number of employees or people exposed. Okay, this is how frequent an activity is performed, the miles driven, a number of vehicles, or number of vehicles used in the transportation when you're transporting hazardous materials, for example. number of customers or products for a product risk assessment. Okay, when you have a particular product released into the market, how many people do you think will be exposed to this product that will use this product? And the number of locations or facilities for a property risk assessment. Okay, we are doing risk assessment in the facility. How many facilities do you think that these risks are that may be exposed to such risk? Okay, for example, like a huge organization that has multiple facilities across the country or even globally. Okay, how many facilities do you think are exposed to this particular risk? So you may want to consider this as well. So here you have a simple description of the frequency and the consequence. I can see for fatal or serious incidents, FSIs, we call them FSIs, fatal or serious incidents, the frequency of occurrence may not be a valid predictor of likelihood, as we said, okay? So pay attention to the statement here. The frequency of occurrence may not be a valid predictor of likelihood or probability unless occurrence data is higher in probability than the exposure. So you use the higher of exposure or occurrence, okay? So you use the higher of this or this, okay? So you might not always want to use frequency of occurrence. Now you can see for this, now we have definition of what is frequent and what is improbable, okay? So for frequency of exposure, you can see that task is performed several times in 1 hour, or duration may approach at least 4 hours in a day. So this is very frequent exposure. As for frequency of occurrence, then as occurred repeatedly within the company, at least on the site, or any of the other previous definitions that we use, like one time in 100 years, or once in 1 week, something like that. Okay, sorry, one time in 100 days, something like this. Okay, or once in a week, things like this. You might use some of the previous definitions we had of frequency of occurrence, or you may also want to consider the frequency of exposure and see which one you think is more accurate in assessing your risk. So you have to use sometimes your intuition, and that's why risk assessment is also considered as an art. It's not an exact science. You also have to use your intuition and your common sense. And especially for FSIs, which is fatal or serious incidents, okay, in this case, it's very necessary to consider both the exposure and also the frequency of occurrence. So let's stop there. Next time, we're going to look at some of these examples of definition or characterization of severity, consequences, severity of the consequences, as well as the frequency of exposure. And we're going to look at some other examples. Okay. So today we'll stop here. Thank you for listening. And